Okay, good morning everyone. Sorry, I give the link quite late, right? I forgot that I didn't give you the link yet. So that's why I was keep waiting why anyone didn't join yet. Right, so sorry. Okay, so for today, who's still not here? We can other than Krisha, is it?
I think everyone is here.
Yeah, but actually it's already
17 minus 3,
three, 14.
14, one more.
Yeah, okay, Krisha already. No one here.
Nirupa.
Oh, Nirupa. Okay. All right, so let's move on to the today lesson. So I hope you already joined the link.
Krisha, what's a group?
Oh, okay, okay. Okay, for a moment. Oh, thank you, Janet. Okay, thank you, Avinash. I think one more is not here, right? Because supposed to be 16. This one is only 15. What's another one? Nirupa. Where's the Nirupa?
I'm not sure. She has not picked up my call since Sajara.
Sejara also, she didn't join.
Yeah, she didn't pick up my call at all.
Oh, okay. Wait, I put in the parents group. Where I go to 4 key. Okay, so can you please try to answer this question first? So this is actually by using the lambda is equals to ax over d. Okay, so this is the formula, right? Lambda is equals to ax over d. So please be careful with your x. Okay. So this one you need to find the lambda. Before I forgot, for tomorrow, okay, there will be no extra class, okay, since we already finished the presentation, right? But for next week, there will be extra class on Tuesday, okay, because Tuesday is the Merdeka Day, right? So actually, I want you to choose whether you want to do the class on Tuesday or on Wednesday. If Tuesday we make with me, we can make it early, like 9 until 10, something like that, to replace the class on Tuesday. Or you want it to be on Wednesday? So later, we can you discuss with your friend?
Teacher.
Uh, Okay, Saji, Venus, Eugene, Trisha. Avinash, Eugene. All right. Okay, so let's check the answer. Okay. So here you want to find the lambda, right? So we need to know what is the A here. So the A is actually the distance between two sources of water wave. So S1 and S2 here. So the distance is 4 cm. Okay, and then the X is actually from the anti-nodal lines to the anti-nodal lines, or from the nodal lines to the nodal lines, or you can see from the constructive interference to the constructive interference, or from the destructive interference to destructive interference. But for this one, they give you already from antinodal lines to antinodal lines. So means from constructive to constructive. So as you can see here, this is actually equals to 1x. Okay, and this one is another x. So means 2x is equals to 16. Okay, so if you want to find only one x, you have to divide. So x is 8 cm. Okay, and how about D? D is the distance between the source and where you measure the x. So already given there 20 cm. Okay, so what happened next? You just use the formula. So 4 times 8 divided by 20. Okay, using this formula. Okay, so you will get 1.6 cm. Okay, good, Izati. Rashmi, maybe you didn't divide. Okay, with 2. For those who got 3.2, I didn't see the dotted. Really? Oh, okay, 8 cm. Then how you get 8 cm?
0 ACM, I went to write 1.6. X 0 ACM.
Oh, okay. 22.86 lambda. Wow. Eugene, how you get 22.86 lambda?
Teacher, mine is wrong.
Oh, sorry, I didn't notice it. Eugene, 22.86. How do you get 22? Okay, so the next one, you want to find the x here. A6 times 20 divided by 14. Where do you got 14 there? Can you understand how do I get 1.6? Okay. So for this one, you have to find the x. Be careful of the unit here because this one is millimeter and this one is meter. So again, you use the formula lambda is equals to ax over d. Now you have to find the x. So means the distance between the antinodal to antinodal, or maybe from the nodal to the nodal line. So how to change the millimeter to meter? Okay, make sure when you change it, okay, when the unit is different, right? So they say the unit, they give you meter, they give you cm, or they give you millimeter, right? Okay, all of that have to change to SI unit. Means you cannot change to millimeter or you cannot change to centimeter. You have to change it to SI unit of the length. That means you have to change to meter. So mm have to change to meter. Okay, not like the meter have to change to mm. Okay, because you already know SI unit is in meter. So all of that, the different unit, all the unit that has different unit, so you have to change it to SI unit of the length, that is meter. Wow, who is it? Okay, Kritika Angela. Teacher, sorry, instead of meter, I put in cm in my answer. Okay. Never mind for this one, but if later, you have to change to meter, okay? For next time. No, teacher, my number is meter value, but unit I put cm. Okay, who's Nirupa already joined the class, is it?
She's in.
Yeah. Okay. Inside. Okay, lambda is equals to ax over d. Okay, so for this one, the lambda is 30 meter. Okay, so this one is actually from crest to crest. So 30 times 10 power of negative 3. Okay, how about the A? The A is 20 times 10 power of negative 3. And what is the x you need to find? And D is 2 meter. Okay, so the answer is 3 meter. Oh. Mm. Sajid, what is the unit for this one? Ketiga, are you sure you want to answer? Oh, okay, this one that you mentioned me just now. Three, three, 300,000. Are you sure? If I change to meter, so 300 change to cm, 300,000. If I change to cm first, you divide by 10, and then you divide again by 100. So it should be that you will get 300 meter. Oh, okay, so this one is wrong. That's why I said change to meter, not don't answer in other unit. 0.03. No. If meter change to millimeter, I thought it's multiply, right? Not divide. Okay. So make sure after this you change to meter, okay, and you have to remember the prefix. Like milli is 10 power of negative 3, centi is 10 power of negative 2, micro is 10 power of negative 6. I think that one is easier. Okay, because this one is milli, right? You already know milli change to cm, cm change to meter. But let's say if they use a micro, something like that, or they use a nano, right? Micro is 10 power of negative 6. So how you want to change it? Okay, unless you remember the prefix, okay, and let's say for nano is 10 power of negative 9, right? So how you want to change to meter? So the only thing is better for you to remember the prefix. So all the prefix I think already give on chapter 1. Okay, so you have to memorize that one. So for the next one is the interference of light. Okay, Can I ask you something? Actually, for yesterday, did I already teach you for this one? Or I stop until here?
This one not yet.
Not yet. All right. So I start from this one. Okay. So interference of light. Okay. So you already learned that for the water wave, they need two source of water. Okay. Then two source of water wave. Okay. Then when they produce, they will overlap with each other, right? So like this. Okay, so at this part is where the interference occur. Okay, when there are two water wave, right, overlap each other. Okay, by using the principle of superposition, okay, you can try to find the amplitude. Okay, for the wave that overlap. Okay, so this is the interference of water wave. Okay, so the next one, what we will learn is actually the interference of light. Okay, so how does the interference of light occur? Is when you point the laser, okay, the color laser. Okay, let's say if you use a red light or yellow or green. Okay, so when you point the laser, okay, into the double slit, okay, double slit, okay, then there will form, okay, on the screen, okay, the bright and dark fringes. Okay, so that is the interference of light. Okay, when you point a light through the double slit, okay, so there will produce the bright fringes and also dark fringes. Okay, so just to make sure that you are not confused, okay, for the diffraction of light, okay, the light pass through one slit only. Okay, but for interference of light, there must be a double slit, so they can form two source of light wave. Okay, then they will overlap. Then what you will see on the screen, they will produce the bright and dark fringes. Okay, so this is the activity, okay, that we're supposed to do. Okay, by using the laser pointer, the double slit, okay, and also the white screen, meter ruler, and also retort stand. Okay, so this is the experiment of interference of light. So after we did the experiment, right, you will see, okay, there will be like this. This will be see on the screen. Okay, there will be a bright fringes. Okay, the red one is a bright one, and the dark one, bright one, dark one. Okay, so this is the interference of light. So this is the effect. Okay, what will happen when the light pass through the double slit. Okay, so this one is actually start the experiment. Okay, and then this one is the result. Okay, then after that, all right, of course you want to know what is the value of x here. Okay, means the distance between the constructive to constructive and destructive to destructive. Okay, so before I forgot, okay, at the part where the bright fringes occur, so that one is a constructive. Okay, and the dark fringes is the destructive. Okay, it's just same as the it's just same as the water wave, right? Okay, so for constructive must be bright fringes, for destructive must be dark fringes. Okay, how you want to find the value of x here? So let's read the measurements here first from the y. Okay, so here is 1.8. This is 9 cm. So means the distance of y is 7.2, right? So 9 minus 1.8 is 7.2. So if I want to find 1x, right? So here it start from the bright one. So bright to bright is 1x, 2x, 3x, 4x. So mean they have 4x here. So and 4x is equals to 7.2 cm. So 1x you will get 1.8 cm. Okay, it's just like the water wave also just now like you answer, right? 16 is equals to 2x. So if you want to find 1x, is just divide by 2. So this one also same, but this one for light bright fringes means the constructive, dark fringes mean destructive. So from the constructive to the constructive is the 1x. Okay, so since it start from the constructive here, okay, so it means from bright to bright. So this is 1x, 2x, 3x, 4x. So 4x equals to 7.2 and 1x is actually 1.8 cm, right? So that's how you want to calculate x. All right, so this one, if you do the experiment, this is the table, okay, that we need to record the value. All right, so the first one, it says the red light from the laser pen is a monochromatic light. Okay, for the water wave, okay, we know that you need to use the coherent source. What does it mean by coherent? Means must have the same wavelength and also must have the same frequency and constant phase difference. Okay, so that is for water wave. We must use the coherent source. But let's say for the light, okay, they must use the monochromatic light. Okay, so what does it mean by monochromatic light? So the monochromatic light must have only one color or means one wavelength. Okay, one color and one wavelength. Okay, so mean you cannot interfere, okay, the wave by using the red, let's say you want to use red one with the yellow one. Cannot, okay, because both have the different wavelength. Okay, so must use the red one, only one color. Okay, one color and they must have the same wavelength. Okay, and here it said describe the interference pattern observed when the light pass through the double slit. Okay, so you can see here they produce the bright and dark line alternately and uniformly. So it's different from the diffraction, right? Where at diffraction you can see there is at the middle there, okay, the fringes is quite big, okay, if you compare with the others one. Okay, so at the middle here they produce the very the quite large, right, the fringes if you compare with the other fringes there, other bright fringes. Okay, but for the interference usually, okay, is uniformly and also it must be alternately. Okay, right, so this is if you do the experiment, right, so this is what you will see on the screen. Okay. Right, so later I will show you a video, right, a video of the interference of light. Okay, so the wavelength of wave. So again, we can calculate, right? They say you want to calculate the lambda, A, X, or D, okay, by using the Young formula. And before I forgot, right, the experiment just now, we call it as the Young double slit experiment. Okay, Young double slit experiment. And the formula that we use is same as the formula that we use for the interference of wave. There is lambda equals to AX over D. Okay, and the lambda is the wavelength of the color. Okay, what is the laser color that you use? Okay, and A is the distance between the double slit. Okay, you have to remember that you use a double slit, right? So here is the distance. This is double slit, so this is the A. All right, and then the D is from the double slit. Okay, it's from the double slit to the screen. Okay, so this is D. Okay, where you can see the bright and dark fringes there. And X, of course, is distance between two successive bright fringes. Or you can take successive dark fringes also. Okay, it doesn't matter as long as from bright to bright or dark to dark. Okay, so that is the value of X. Okay, let's say for this one, okay, can you try to answer this one by using the lambda is equals to AX over D? I know it's already, you can see already the answer. Oops, not side drawing. Okay, let's try to answer this one. Okay, so again, by using the formula lambda is equals to AX over D. This one, 1.8, we already discussed how you get the X just now. Okay, you just measure 9 minus 1.8, then after that, you divide it by 4. Okay, because there are 4X there. I want you to find the lambda. Is there anything you want to ask about the interference? Can you really understand?
Teacher,
Yes?
so the X and A must
Mm-hmm.
change to M
Yeah.
later. Okay.
Yeah. Yeah. Correct, Sajid. Who submit this one, the first one? Did you already convert? Ketiga, you already convert to meter, right?
Yes, teacher.
Okay. So usually what the prefix that usually physics, okay, use is you maybe you want maybe it's hard for you to remember all of it, right? Okay, so make sure you know mega, okay, milli, nano, micro, centi, mm, yeah, I think this one is the most frequently that physics use this prefix. So maybe you can just remember these five. Teacher, I am getting very small answer. What is your 10 power of negative 7, is it?
Yes, sure.
Yeah, yeah. The answer is 4.5, I think, if I'm not mistaken. Because this is the wavelength, right? So wavelength usually is very small for colors. Put my unit cm. But the answer is correct. Only you put the wrong unit, is it? Forgot to put unit. Okay. So remember, in exam, make sure you have a unit, okay? Because starting in KSSM, the unit is important. Before this, they didn't bother about the unit, but now the unit is important. Okay, we wait for another 3 more. Who is it? Tava, Asher, and Farah. Mine answer is in meter. Yeah, the answer should be in meter, but it's very small. Asha? Okay. All right. So we use lambda is equals to ax over g, right? So a is 0.5 times 10 power of negative 3. Okay, while x is 1.8 times 10 power of negative 3. And d is already in meters, so you don't need to change. So you will get 4.5 times 10 power of negative 7 meter. Okay, yeah, it's actually 10 power of negative 7. Okay, good. We can, oh, 1, 2, 3, 4, 5, 6. Exactly, this answer is wrong. Okay, I'm not saying this answer is wrong, but actually when you got it the answer like this, right? It's better for you to change it to to standard form. Okay? Because if like this, um, I don't know how to say it, but it's better for you to answer. This one is more simple, okay, and of course you already learned this one, okay, form 3, right? How to change to standard form. Okay, this one is 0, 0, 0, 0, 0, 0, right? So change it to the standard form next time, okay? Uh, mm, one. Like if you answer like this, then the teacher have to see whether it's correct. 4, 5, 6, 7. Okay. cm, I thought it's meter, right? Oh, how you get 4.5 meter? Where the 10 power of negative 7? Did you miss it? Okay, Abi? Nirupa, how you get negative 4? Did you use the correct prefix? Tava, this is wrong. 10 power of 7.
Teacher, it's actually -7. I accidentally put 7.
Oh, okay. So you left the negative sign. Wrongly press submit. Okay, good. Okay, so this is the example how you calculate, right? Using the formula lambda is equals to ax over d. So I think I already just discussed this now. Okay, so this is the another questions, okay, for you to answer. For this one, you have to find the lambda, okay? And be careful again about the unit and also the x here.
Teacher,
Yes?
the 2.44 mm is until the one, two,
Until
the
from
fifth,
here to here.
until the fifth one, right?
Yeah.
Okay.
Wait. Forgot to put my net that is meter. Okay.
Teacher, this one the answer also very small, right?
Yeah.
Okay.
Okay. Avina, Sharina, Asher, Nirupa. Okay, Asher. Okay. Right. So let's check the answer. So for this one, use lambda is equals to ax over d. So you want to find the lambda here. So A is actually the distance between two slit here. So there is 20 millimeters. So I change to meter. Right, why x? Yeah, so x is actually, you have to count how many x is there. So 1, 2, 3, 4. Okay, because it's starting from the bright, right? So bright to bright. So 1, 2, 3, 4. So 2.44, you have to divide by 4 because 4x is equals to 2.44. So this one is actually the x. Okay, so x is 2.44 divided by 4. So you will get 0.61. Okay, then again you have to change to meter. Okay, then how about the D? D is 2. So the next part you have to just multiply it. Okay, times 0.61 exponent -3 divided by 2. So you will get 6.1 times 10 power of -6 meter. Okay. Janet, how you get 1.22?
Instead of dividing by 4, I divided by 2.
Oh, okay. So Jay, how you get 4.88? Okay. So can you understand how did I get 6.1? Anyone have problem? Can you understand? For those who got it wrong. Eugene? Farah? Eugene, Farah, Tava? Are you clear? Okay. So let's try another one. For this one, you have to find the A. Yeah, so remember that one I use nanometer. So what is the prefix for nanometer?
Teacher, this one it begins from the bright or the dark?
You start from the bright also.
Okay.
Sure. For this, the answer is very big value.
Very big, yeah.
Okay, teacher.
Mm. And power of this equals this. You got 1.6 times 10 power of 7, right?
Yes, teacher.
You can send to kilometer.
You just change to meter. Put it in the standard form and the unit is in meter.
Teacher, 10 to the power 7, right?
Yeah.
Okay.
1.6 times 10 power of 7. So that's the answer. Before I forgot, all right, I will put a folder, okay, in the Google Classroom, okay, for you to upload, right, your, maybe I put in the Google Drive lah, right, for you to upload the CJ, all the CJ that you got for the Coco, right? Okay, so can you please upload in the Google Drive? Okay, so later when I key in your PAJSK, right? So I know. For your pelibatan.
Teacher, I refresh my email day and night, also no CJ.
Really? Did you ask the teacher that, involved in the competition, we in charge?
I don't know. Maybe
What,
later I go check.
what is the competition exactly, or that you just enter?
I don't know. They just send the link there and then I just click and masuk.
Okay, then you just inform me what is the competition. Then maybe I can tell you which teacher in charge of that.
Okay.
Okay, so who is still not? Teacher, I forgot to divide the X, so I got wrong answer. Can you put your the right one on the chat? Ashir, Farah, and Nirupa. But me and Vikan got Coco marks for the physics competition, right? Actually for that one, they didn't announce yet. Okay, I don't know why. Okay,
Teacher, it's been so long.
they didn't announce yet because some of the teacher also asked in the group, when will the result will come out, right? So it said you have to wait for the jabatan, to give the green light to announce it. So I was like, okay, fine, never mind. So actually for you to get the CJ, right? You need to like got 20%, I think, the marks, then you can get the CJ.
So
I think they
10,
already mentioned about that.
so 10% also cannot get it. So hard.
Really? Who
They
knows?
asking for
Maybe
gravity law lah, the law of something, don't know. And then they're asking what does this symbol mean lah, what that symbol mean. Then both of us was like, oh, okay lah.
it's not just you lah. Actually, everyone in the other school also complain the same one because the question is quite hard, right? It's not like the one that we learn in the physics. That one is advanced. Okay. So and you have to know that some of the topic they learn in chapter form 5. Okay, and because there's no one to take part on form 5, I think. So I just offered to form 4. Never mind. Let's see. Okay, what's the result?
Okay, teacher.
Okay, so some of you got 6.25. Okay, so let's check the answer. Lambda is AX over D. So lambda is 10 times 10 power of negative 3. So AX is 5, right? This one is 1, 2, 3, 4. Okay, from bright to bright. So 5 nano is negative 9. So you have to divide by 4 to find X. So I think just now when I divide, for 1.25, right? So 1.25 times 10 power of negative 9. So D is 2 meter. Okay, then after we solve the equation, I will get 1.6, right? 1.6 times 10 power of 7 meter. You forgot to put the unit. Lashmi, how you get 400? This is 4 million, right? 4 million. Are you sure you calculate it correctly? Ava, Krisha, Janet. Okay, for those who got this one wrong, can you understand why your answer is wrong here? Do you know how I substitute? Where is A? What is X? What is D? Lakshmi? Eugene? How you get 4 times 10 power of 6? And Tava, how you get 0.2 times 10 power of negative 7?
I divided 5. That's why wrong.
Oh, you count the fringes, is it?
Yeah.
Oh.
Yeah.
Okay, Eugene? I tried to change nano. Oh, nano is 10 power of negative 9. Okay. All right. Nirupa, how you get 6.25? Yes, all right. Okay. Okay, so the next one it says, what will happen to the fringes on the screen, okay, when the distance between the double slit and screen is decreased. Okay, so for this one, you want to answer, you have to know the formula. We just use the formula. Usually, when the physics question asks you what will happen to the fringes, what will happen, when they ask you what happened to the physical quantity given, okay, so you just refer back to the formula. So this one, let's say I'm using the lambda is equals to AX over D. Okay. And you already know the fringes is actually X, right? The distance of the fringes is actually X. And they ask you the distance between double slit and screen. So this one is what? AX, lambda, or D? Which one is representing the distance? What?
D.
D, yeah. So means you have to find what is the relationship between D and X. So we just arrange back the formula. Okay, so D is equals to AX over lambda. Okay, so here it says when the distance between double slit is decreased. So D is decreased. So what happened to X? X also will decrease. Okay, so we just use the formula, okay, and you just arrange, right, the formula to find the relationship between D and X. Okay, and for B, yeah, for B, you have to remember this color, the color of the rainbow, right? Red, orange, yellow, green, blue, indigo, violet. Okay, so as they move from red to violet, the lambda will be decreased. The wavelength of the color will be decreased. Okay, so when we know this one, okay, so lambda is equals to AX over D. Again, we use the formula. So when you change red to blue, what will happen to the wavelength here? Red to the blue, the wavelength will be decrease or increase?
Decrease.
Okay, so means the lambda will be decreased. So what happened to the X? The X also will decrease. Right? Why? Because the wavelength of the color, right? Means the red has the higher wavelength than the blue one. Okay, then the next one, the distance between the double slit is increased. So the distance between double slit is increased is what? Lambda A, X or D?
A.
A. Okay, so lambda is AX over D. Alright, so here you want to find the relationship between the X and also the A. So lambda D is equals to AX, lambda D over A is equals to X. So let's see if I increase the A here, the X will be decreased. It's like an inversely proportional relationship. Okay, so that's how you want to find, okay, the relationship, okay, between lambda and between D and X, okay, lambda and X, and also A and X. Just use the formula. Okay, so that is for the interference of light. So let's see a video, okay, to show the interference of light. Okay, wait for a moment. Yeah. Okay, so this one, okay, this one is the interference of light. So let's see a video, okay, to show the interference of light. Okay, wait for a moment. Yeah. Okay. So this one is the interference of light. Okay, wait for a moment. Yeah. Okay. So this one is the interference of light. Okay, wait for a moment. Yeah. This is diffraction. This one that I already show you. Okay, so this is for the interference, right? They use a 3 laser that we have a different wavelength. So they use a red laser, yellow laser, and also the green laser. Okay, and they make it pass through the double slit. Okay. So you can see here the fringes, right? The size of the fringes. So if you compare with the red, yellow, and also another one is green. Okay. So as we know, right, the color from red to violet. Okay. So the color, the lambda is decreasing. Okay. So here the lambda is decreasing. So if you can see, all right, and we use the formula lambda is AX over D. Okay, so red, yellow, and also green. Okay, red, yellow, and green. So means the lambda is decreasing. Okay, and you can see the size of the X also will decrease. Okay, you can see the size of the X also is decreasing. All right, so this is actually to see that actually the color of the wavelength of the light, all right, will affect the interference of light. Right, so they use 3 different colors. So you can see they form a bright and dark fringes here. Okay, so we move on to the next one. Okay, interference of sound. So we already see interference of water wave, interference of light. Okay, now what we will do, we will learn how does the sound be interfered. Okay, so you have a 2 loudspeaker, right? They have a 2 loudspeakers, so you know already each of the loudspeaker will produce their own wavelength. Okay, they will produce their own wave. So this wave also will overlap and produce the interference. Okay, so the 2 loudspeakers are the source of 2 coherent sound wave. Why? Okay, because both speakers are connected to the same audio generator. So what can you observe when the 2 sound wave overlap? So you can hear the loud sound and also the soft sound alternately. So explain your observation. So the loud sound is actually for the constructive interference. Okay, while the soft sound is actually for destructive interference. Okay, so why this experiment must be done in the open area? Because this one to avoid the reflection of sound. Okay, so you have to do in the open area to produce the interference of wave. If not, all the wave also will be reflect at the same time while the interference occur. Okay. So the wavelength of wave can be calculated using a Young formula. Alright, so this one same. Use the lambda is equal to AX over D. Okay, so maybe this one is missing. So this is the A. Okay, lambda is the wavelength. Okay, see this one, they got the diagram here, the formula here. So lambda is the wavelength. A is the distance between 2 loudspeakers. So this is A. Right? This is A. Okay. And X is the distance between the, D is the distance between the loudspeaker where X is measured. So let's say from here, okay, let's say you measure this is the listener. So it's from the listener to the source of the sound. So the source of the sound here is the loudspeaker. So this one we call it as a D. Okay. And another one is X. So X between the 2 successive loud sound. So it doesn't matter from the loud sound to the loud sound. Okay, you can also take from the soft sound to the soft sound. Okay, so whether it's to the loud sound or soft sound to the soft sound, it's just same like the one that for the interference of light, right? You take from the bright to the bright, or you can take from the dark to the dark. It still equals to X. Okay, but for the interference of sound wave, the X must be come from the loud to the loud or soft to the soft. That is equals to 1X. Okay, so for this one, I want you to try it first. So if you are wrong, I will teach you how to do it. Right? So let's try to this for this one. This one is for the sound wave. Okay, just use the same formula. Lambda is equals to AX over D.
Teacher, answer emitter, right?
Yeah, answer must be emitter.
Alright.
Okay, is it okay? Can you try? Can you answer it? I
Sure,
think yes.
I made a mistake. I
Again,
went to number 2. I answered number 2 instead of number 1.
Can you put your correct answer in the chat?
Yes, I
Okay, who is it? Another one? Right. 1.5, 0.67. Okay. So in the experiment on the interference of sound wave, two loudspeakers are placed at a distance of 2 meters from each other. So means the distance of the two loudspeaker is 2 meter is actually A, right? So A is 2 meter. And the distance between two consecutive loud sound is 1 meter. So it means the X is 1 meter. And the listener is at distance 3 meter from the loudspeaker. So this one is D. Okay. The distance between the speaker and also to the listener is just like listener is acting if in the lights like a screen, right? So the screen to the double slit is the D. That is for the light. Okay. For the sound is from the listener to the source of the sound that is a loudspeaker. So D is 3. So we want to find lambda is actually AX over D. So 2, so 0.67 meter. Then your answer is 0.67, is it? Okay,
Yes.
Farah. Okay. So Farah, 6.66. Okay, you change to standard form. Oh yeah, so it should be 6.67, right? Okay, very good, Eugene. Abi? Asha, good. Alright, this one you change to standard form. Tava, how you get 1.5? Okay, and this one is for water wave, right? So you just use the same lambda is equals to AX over D. Okay, but this one you have to make sure which one is AX and D. Okay, this one they ask you to find the lambda.
So also in meter.
This one no need because all is already in cm. It's okay.
Okay.
If like maybe some is millimeter, some is meter, then all have to change to meter.
Teacher,
Yeah.
meaning of two consecutive antinodal line means from one antinodal line to another antinodal line, right?
Yeah, two consecutive. Yes.
Okay, teacher.
Okay. Teacher, my unit are supposedly CM, but I tak terletak M. Ayo. Later in exam, don't be like this, huh? You will have the online exam, you know. I mean, for my subject, for physics, I will have an exam. Okay, online. So make sure when you submit, you have to check.
Will that be like quizzes?
Oh no, I'm not using physics. I'm using the class time.
Alright.
The new one. I'm trying to use it. When teacher, I'm doing the question now. We start with chapter 1 and chapter 2 first. I will just do like two chapter. Let's say chapter 1 is too short, right? So I will combine it with chapter 2. And chapter 3, maybe I will combine it with chapter 3 is only chapter 3. Maybe chapter 4 and 5 I will combine it. Yeah, and that is will help me to like to do my to do for your PBD assessment. Okay, and like for my record. No need to be takut lah. The question is just like the normal one that we already always answer in the class. Can I send? Yeah, yeah. Sure, Nirupa. Okay. There will be the structure question and also the objective. Essay, maybe lah. It depends. Okay, in experiment on the interference of water wave by using a big water tank, the distance between two vibrator is actually too deeper there, is 5 cm. So means the A is 5. Okay, and the distance between from the vibrator to the position where antinodal line is observed is 50 cm. So that means the the D is 50 cm. Okay, while the distance between two consecutive antinodal line is 60 cm, so mean this one, the X is 16. So you have to find the lambda. Okay, so 5 times 60 divided by 50. So you should be 80, right? 80 divided by 50 is 1.6, I think. Yeah, 1.6 meter. cm. Okay, very good. Tava, how you get 15? What happened, Tava? Nirupa? Okay. Tava, how you get 15? Can you understand how do I get 1.6? Okay. Actually, this one we already answered, so I don't think so we need to answer it again. Oh, no, no. We can answer this one. We can answer this one. This one is different. You can see the X there. Ava, make sure you answer this one correct, okay? We already discussed this one. Just the 16 cm, the S value is different.
Teacher, answer in CM, right?
Yeah, yeah, answer in cm.
Okay, thank you.
Okay. 0.8 I divide by 2 instead of 4 again. Just put your correct answer in the questions in the chat. Sorry. Hey, Abi, Avinash. Ring lag. Okay. All right, so let's check the answer here. So lambda equals to ax over d. Okay, so the lambda here you need to find. A is 4, x is, all right, 1, 2, 3, 4. So means there is a 4x here. Okay, from the antinode to the antinodal line. Okay, so antinodal to the antinodal line, there are 4x here. So 16 divided by 4, you will get 4. So D is 20. So I think you will get 0.8. Okay. Is it? Okay. Okay, this one that you mentioned to me just now, right? Trisha, also same. Okay, very good, Tava. All right. Okay. So this is the next question. Okay, the last one before we stop. So it says here, in an experiment on the interference of wave, two loudspeakers are placed at distance 1.5 meter from each other. So they are connected to an audio signal generator to produce the coherent sound wave at the frequency 0.5 kilohertz. Right, so calculate the wavelength of the sound if the speed of sound is 300 meter per second. And B, you have to calculate the distance between two consecutive soft sound at the distance of meter from the source of the sound. Okay, so this one means you have to use two formula. For A is one formula, for B is another formula.
Teacher,
Yeah?
this one have to use the V equals to F lambda.
Yes.
Ah, okay.
Okay, can you answer this one?
Teacher, for B, you have to find the X, right?
Yes.
Okay.
Forgot to put meter again. Okay. Is it hard?
Okay.
Okay, give you already 11:49. Okay, so you have chemistry class right after this?
Yes.
Okay, I will just close the submission. If you want to answer, you can put your answer in the chat. Okay. All right. So let's check for this one. It says the two loudspeaker are placed at distance at 1.5. So means A is 1.5. So they are connected to the audio signal generator that has a frequency of 0.5 kilohertz. So 0.5 kilo is 10 power of 3. Okay. And the next one, you have to calculate the wavelength. So we use the formula here, V is equals to F lambda, right? So already give you the speed that is 300 Okay, and the F is 0.5 times 10 power of 3. Okay, then you have to find the lambda here. Okay, so 300 divided by 0.5 exponent 3. So you will get 0.6. Okay, so the lambda is 0.6 meter. Okay, for the next one, B, you have to find the distance between two consecutive soft sound. So mean that one is X. Alright, and a distance of 5 meter from the source of sound. So where you measure the soft sound to the where you measure the soft sound and the source of the sound, okay, we call it as a D, right? So D is 5 meter. So now you have to find the X. So lambda is equals to AX over D. Lambda we already calculate for the A part here. So 0.6. Okay, A is 1.5. X you need to find. D is 5. So 0.6 multiplied by 5, you got 3. 3 divided by 1.5, you will get 2. So actually X is 2 meter. Okay. 600 meter. How you get 600 meter? Eugene, this is for what? A or B? I didn't change 0.5. Isha, I get 0.18. Ninja, where's the A part?
I accidentally times teacher. I'm supposed to
Oh.
divide.
Okay, so Izzati also got same as Sajid. Okay, so can you understand for this one? Anyone have a question before I stop?
No, teacher.
Okay, so I will stop until now. So I will see you on next week, okay, on Monday. Okay, so we will continue with the rest of the question here. Okay, so thank you everyone. Okay, take care. Okay, bye.
Thank you, teacher. Bye.
Okay, bye. Take care.
Thank you, teacher.
Okay,
Bye.
teacher. Bye, teacher.
Thank you, Chaba.
Bye.